Imagine an AI that doesn't just, read words on a page. What if it could also see the complex charts in your business presentation or hear the subtle emotional tone in a customer's voice and really understand the nuances of a video all at the same time? It's almost like artificial intelligence is suddenly learning to perceive the world much more like we do. Today, we're taking a deep dive into multimodal AI. It's being called a genuine game changer, and it combines text, images, audio, video, all into one incredibly powerful system. Our mission really is to unpack what multimodal AI is, how it works, look at some cutting edge real world applications, and, well, why it's set to transform pretty much every industry you can think of. And I really mean transform. Get this, back in 2023, only about 1% of AI tools were multimodal. Tiny. But fast forward just a few years, by 2027, that number is projected to explode to 40%. And the whole market could hit, nearly $11 billion by 2030. So understanding this isn't just for the tech experts. It's kind of your shortcut to being really well informed about the future of automation, of problem solving. It gives you those aha moments about how complex stuff is suddenly getting simpler. So let's start there. What exactly is multimodal AI, and what makes it such a big deal, such a leap forward?
Well, at its core, multimodal AI is about bringing together different types of data. We call these modalities, like images, sounds, text, all into one system. So a modality is just a specific input type, visual, auditory, textual. You get the idea. Traditionally, AI systems really only focused on one, but by combining them, multimodal AI starts to mimic how we humans process information. It creates a much richer, more complete picture. Like the folks at Splunk blog said, it can handle multiple data inputs, resulting in a more accurate output. And that integration, it really cuts down on the ambiguities you sometimes get with single-modality AI. You get a much more nuanced, almost human-like understanding of context.
That's a really powerful difference. We've all gotten used to large language models, LMMs, right? They're amazing with text. But this feels like the next step, moving to large multimodal models, LMMs that understand images, video, audio too. How big is this leap, really? What does it unlock?
Oh, it's absolutely foundational, a huge leap. LMMs pull this off by using, well, massive data sets and really advanced neural network designs. These help them spot complex patterns across these different data types. A good example is Meta AI's Llama A 3.2. That came out in September 2024, open source, and it processes text and visuals together simultaneously. And what's really cool is how they use these things called attention mechanisms.
Attention mechanisms.
You think of it like the AI learning to focus. Just like your brain prioritizes what you see or hear, the AI learns to pay attention to the most important parts of the data. They use both local attention, focusing on tiny details, and global attention, understanding the big picture. And that gives them incredible precision, incredible adaptability, especially in really complex situations. So this shift in capability, it's profound. Single-modality AI, it's kind of stuck handling one data type for specific tasks. But multimodal AI, it juggles multiple types at the same time. That means it excels where things get complex, multi-layered. Older systems might have limited context from just one input, right? But multimodal AI combines inputs to this vastly richer understanding. It's not just about being more efficient. It means AI can now connect the dots between different pieces of information, dots that maybe even an experienced human might miss because there's just so much data. It leads to these holistic insights we couldn't really get before. It's like giving AI a sixth sense for data.
Wow, that really does sound like a new era. So who are the big players then? Who's leading the charge in this LMM space? Which ones should we be watching right now heading into 2025?
Right. It's a really fast-moving field, but the powerhouse is defining things right now. Definitely Google Gemini, OpenAI's GPT-4o, and Anthropic's Claude 3. And each one has its own kind of flavor, its own strengths. Google Gemini is maybe the most versatile. It handles text, images, audio, and video natively. Its latest version, Gemini 2.5 Pro, has this mind-blowing 1 million token context window.
1 million tokens? What does that even mean in practice?
It means it can process, like, entire books or the full transcript of a really long video all in one go. Huge amounts of information.
Yeah.
Samsung actually put Gemini into its Galaxy S25 phones this year, so you can see it's already hitting the real world.
Okay.
Then you've got OpenAI's GPT-4o. The one's really known for its precision with visual stuff, photos, screenshots, even complex scanned documents. The newer GPT 4.5 has 128,000 token capacity, which helps it tackle tricky tasks like interpreting detailed graphs or charts. Okay. And finally, there's Anthropic Claude 3. That one's designed more for conversational ease, sort of interacting with you about images and text. The Claude 3.5 version, It has a 200,000 token context window, great for digging into massive projects or, analyzing large code bases.
So different strengths, different use cases almost.
Exactly. And the key thing is these models process all these data types natively. They don't need to convert things first. That leads to much more efficient processing and, well, richer insights. Think about Gemini analyzing a business presentation. It sees the charts, hears the spoken narration, reads the written notes, and understands it all together as one thing. That kind of integrated analysis, that's the real game changer.
That's an incredible lineup. It really makes you wonder, okay, how do these incredibly complex systems actually do all that? What's going on under the hood?
Yeah, absolutely. So fundamentally, these LMMs are built on something called transformer architectures. And they use those self-attention mechanisms we talked about. These help them find relationships within a data type, like words in a sentence, but also across different data types, like connecting an image to its description. Think of it like this. Each piece of data, an image, some text, an audio clip, goes through its own special encoder. These encoders turn the inputs into numerical representations. We call them embeddings.
Embeddings, like digital fingerprints.
Kind of, yeah. You can think of it like giving each piece of data its own unique numerical address on a huge digital map. This map lets the AI see how different pieces of data relate to each other, even if they're different types. So, the word cat might be near the word kitten on this map, but it might also be near an actual image of a cat if the map includes visuals. These numerical addresses, these embeddings, are then all combined into one unified input sequence. That's how the model bridges the different modalities so smoothly. And what's also really interesting are some recent innovations, like something called mixture of transformers, or MOTI.
Modi.
Yeah, mixture of transformers. It's a clever way to significantly cut down on the computational power needed, but without sacrificing performance. They found MAT could get similar results using like half the computing power, and even less, maybe around 37% when you add Siege as a third modality.
Wow, so much more efficient.
Exactly. And what that really means is these super powerful AIs can run using way fewer resources. That makes them more affordable, more accessible for businesses, puts multimodal power into more hands.
Okay, so they have this foundation, they can process all this data, but how do we make sure they're actually doing what we want them to do? How do we refine them so the outputs are accurate, but also, safe and aligned with what humans expect?
Right, that's absolutely critical. That's where training and fine-tuning come in. So first, the raw data gets turned into those embeddings we mentioned. Then they're fused together. The model's internal parameters, basically its settings, are adjusted over and over to make its predictions closer to the actual data it's learning from. But the fine-tuning stage is really key. This is where the model specifically learns how different modalities connect, like associating spoken words with the right visual scene. And a major technique here is called reinforcement learning with human feedback, or RLHF.
RLHF, heard of that one. How does that work?
So RLHF basically uses human ratings to steer the model. Humans look at the AI's responses, evaluate them, rank them. This feedback is used to build a reward model, essentially teaching the AI what a good output looks like from a human perspective. OpenAI did some powerful research showing how effective this is. They found human testers actually preferred outputs from a much smaller 1.3 billion parameter model that used RLHF over the gigantic 175 billion parameter GPT-3 model without it.
That's surprising. Smaller, but better aligned.
Exactly, and their studies with GPT-4 showed RLHF could actually double the model's accuracy on really difficult questions. So it's all about getting those AI predictions to line up better with human judgment and intentions. It's really powerful stuff for safety and usefulness.
Okay, these advancements are incredible, but I imagine LMMs still face some hurdles, like data quality must be a big one, and just the sheer computing power needed. What are researchers doing about those?
Yeah, those are definitely crucial challenges, and researchers are working hard on them. For data quality, they're using things like advanced filtering techniques, semi-supervised learning, basically ways to improve data sets without needing humans to manually label everything. They also leverage huge amounts of web data. And on the computational side, they're using techniques like sparse attention mechanisms, making the attention more focused and efficient, plus model quantization and pruning.
Quantization and pruning, or trimming the fat, basically.
Pretty much. It's all about optimizing performance, reducing delays, cutting down resource use, making sure LMMs stay practical and scalable so they can actually be used in the real world. It's about making them smarter, faster, and more efficient.
Right. Okay, so we've covered the how and the who. Let's get back to the what's. What can these LMMs actually do right now? Forget the hype for a second. How are they really impacting industries today, especially with that, nearly $11 billion market projected?
Oh, the capabilities are already surprisingly diverse and, yeah, deeply integrated in some areas. Take image description and analysis. LMMs are digging into visuals for really deep, actionable insights. In retail, they're generating detailed product descriptions for things like groceries or ready meals, cutting way down on manual data entry. In manufacturing, they can look at visual inspection data, merge it with production details, and spot potential defects before they even happen.
Proactive quality control.
Exactly. And in healthcare, this is huge. They can correlate imaging data, X-rays, MRIs, with patient history, demographics, treatment protocols, leading to much better outcomes. Now, IBM Watson Health was already doing work integrating health records, doctor's notes, and imaging to improve diagnosis. And think about car insurance. If you have a minor accident, LMMs can now analyze photos of the vehicle damage, pinpoint the issues, and estimate repair costs almost instantly.
That's pretty amazing. And it's not just about understanding images, right? You mentioned they're changing software development too. Code generation from mockups. How does that work?
Yeah, that's a real game changer for developers.
Hmm.
LMMs can literally look at a design mockup or a wireframe and spit out functional code, HTML, CSS, JavaScript, even code for mobile app frameworks.
Seriously, from a picture to code.
Pretty much. It dramatically speeds up the prototyping phase. It means developers can focus less on the tedious initial coding and more on refining the user experience, the complex logic. It just accelerates that whole development cycle, lets teams innovate faster. And then there's voice interaction and audio analysis. LMMs are great at turning speech into text, sure, but also analyzing emotional tone in the voice and even converting text back into natural-sounding audio.
So real conversations, understanding nuance.
Exactly. In the automotive world, for instance, there's a company, 704 Apps, using Gemini to monitor the emotional temperature inside a vehicle. It listens for keywords like robbery or assault and can trigger alerts immediately.
Wow, safety applications.
Definitely. And Volkswagen's My VW app. It lets drivers use voice commands to ask questions about their owner's manual. Or, get this, they can point their phone camera at a dashboard warning light, and the app, using multimodal AI, identifies it for them.
That's incredibly useful.
It is. And in retail, think about self-checkout. LMMs are powering these smoother systems that combine voice commands, visually recognizing the items you're scanning and handling the payment process. It's all becoming one seamless, integrated experience.
That really is where the magic happens, isn't it? Taking all this amazing tech and actually weaving it into everyday business. How are companies making that integration easier? Are there specific platforms helping out?
Yeah, this is where these AI orchestration platforms are becoming really important. They act as the bridge. They connect the powerful LMMs to the practical business workflows people actually use. Latenode is one example we looked at. It centralizes access to hundreds of AI models, GPT-4, Gemini, Claude, you name it. And the key is they often offer a visual workflow builder. So you can drag and drop, connect these models to your apps without needing to be a coding expert.
Making it accessible.
Exactly. Though they usually have JavaScript support too if you do want to customize things further. But the main appeal is the simplicity. Like one user said, these platforms make it super easy to use because they handle all the tricky stuff like API keys and billing in the background.
Okay, let's talk results. Can you give us some concrete examples, real-world workflows where businesses are using this multimodal automation?
Absolutely. Anastasia Antonova, one of the founders at Latenode, she actually built an automated SEO content workflow. It finds trending topics online, pulls relevant content, uses Gemini 2.5 Pro to analyze it for SEO, and then generates optimized articles.
And the results?
Pretty impressive.
Yeah.
She said each article costs maybe 40 to 60 cents to produce, takes about 10 minutes start to finish, and they started ranking on Google's second page really quickly. Imagine the time and cost savings there.
Huge efficiency gain.
Totally. Or think about a retailer. They could set up a workflow where whenever a new product image gets uploaded to their system, it automatically triggers an LMM via a platform like Latenode. The LMM generates a detailed description, pulls out key features, and updates the product database. All automatic.
Zero manual input needed for that part.
Right. And there are even these voice-to-content workflows, like a template called speech-to-post. You record a voice note, maybe you're rambling some ideas, and the workflow uses an LMM like ChatGPT to turn it into a polished social media post. It might even use another AI tool to generate a relevant image to go with it. These platforms really unlocks a ton of creative and efficiency potential across so many areas.
What an incredible journey we've taken. We've really seen how multimodal AI is fundamentally changing the game, haven't we? Enhancing efficiency, accuracy, user experiences, all by getting closer to how humans actually understand the world and that growth trajectory. from just 1% in 2023 to maybe 40% by 2027, that huge market value. It just hammers home the impact this is having.
Absolutely. And it's not just us saying it. Scott Likens at PwC, he's their chief AI engineering officer, he noted, multimodal AI can tackle more complex challenges, create more personalized experiences. It's about versatility and deeper insights, which are crucial to staying ahead.
Deeper insights, yeah.
And Arun Chandrasekaran over at Gartner, he put it simply, it enables use cases that previously weren't possible.
Hmm.
The future really does seem to belong to those who can effectively, orchestrate all these advanced capabilities, turn the potential into practical, real-world solutions.
Indeed. It leaves you thinking. As AI gets more and more human-like in how it perceives things, seeing, hearing, understanding context, what new frontiers does that open up for human-AI collaboration? And maybe more importantly, how will you, listening right now, leverage these integrated intelligences to tackle problems in your own world? Something to mull over.